Correlation coefficients. Introduction. In many studies, we measure more than one variable for each individual. For example, we measure anxiety in relation to achievement, therefore, we collect pairs of data. Instead of examining each variable separately, univariate data, we aim to find ways to describe bivariate data, where two variables are measured for each individual in our sample. When working with this data, we begin by determining whether there is a relationship between these two variables. When the values of one variable change, do we observe corresponding changes in the other variable? Definition. Correlation is defined as the statistical relationship between two variables. There is a correlation between two variables when one is related to the other in some way. A scatterplot, counting spreadsheet, is a better method for determining the nature of the relationship between two variables. Spreadsheet, it is a graph of paired data, x, y, taken from the sample, where there is a horizontal, x, axis and a vertical, y, axis. Each odd pair of x, y values is represented as a single point on the graph. Maybe for the spreadsheet identify several different types of relationships between two variables. 1. A relationship is uncorrelated when the points on the scatterplot do not show any pattern. When there is no relationship between two variables, there is neither a linear nor a nonlinear relationship between them. When one variable changes, it does not affect the other. 2. A relationship is nonlinear when the points on the scatterplot follow a pattern but are not a straight line. Nonlinear relationships have a clear pattern, but it is not linear. Example: with increasing age, height increases until it reaches a certain point, then stabilizes after reaching maximum height. 3. A relationship is linear when the points on the scatterplot follow a nearly straight pattern. This is the relationship that we will study it. Linear relationships can be either positive or negative. Relationships positivity it contains points that tend upwards towards the right. As the values increase, x values increase, and when the values decrease, x the values are decreasing. Y. Example: there is a direct correlation between the motivation to achieve and self-confidence. Values increase, x values increase. There is a direct correlation between lack of sleep hours and muscular effort. Values decrease, x the values are decreasing. Y. Relationships negativity it contains points that slope downwards towards the right. As the values increase, as x values decrease, y values increase, and as x values decrease, y values increase. Example: there is an inverse correlation between psychological adjustment and shyness. Important note: correlation does not mean causation. Just because there is a correlation between two variables does not mean that one causes a change in the other. Pearson's correlation coefficient. Pearson's correlation coefficient, Pearson's R, is a statistical measure used to determine the degree, strength, and direction of a linear relationship between two quantitative variables, interval or ratio measure. It is one of the most widely used parametric methods. Its function is to estimate the relationship between two variables. It is the common variance between two variables and y, that is, whenever it differs xi disagreed with him y. Ranges Pearson's are between 1 and +1. R equals +1 indicates a perfect linear relationship. As one variable increases, the other increases in the same proportion. R equals -1 indicates a perfect linear inverse relationship. As one variable increases, the other decreases by the same proportion. R equals 0 indicates that there is no linear relationship between the two variables. Important note: in the field of social sciences, Pearson's value ranges between 1 + 1. There is no value A equals 0. Its conditions: normality of data distribution, linear relationship between variables along a line, quantitative variables of at least one interval level. It is calculated using the following. This formula. Statistical significance law. After calculating the Pearson value, we convert it to a t-value. We obtain a calculated t-value and a tabulated one to compare it with, and we make a decision based on the level of significance and degree of freedom. If the calculated value is greater than the tabulated value, then we reject the null hypothesis. If the calculated value is less than the tabulated value, then we accept the null hypothesis. Degree of freedom T equals N2. Example, we have the IQ and need for cognition scores for a sample of students as follows. Intelligency, 10897325. Need for knowledge X 7568425. Required, estimate the correlation between the two variables. The solution. Identify the problem is there a correlation between knowledge and intelligence among students. Formulating hypotheses. H0 there is no correlation between knowledge and intelligence among students. H1 there is a correlation between knowledge and intelligence among students. R equals 0.78. Decision making. Converting the Pearson coefficient value to a t-value to calculate statistical significance. T equals 3.11, calculated. We compare the calculated t with the tabulated t. We have an undirected hypothesis, with two ends or two tails. df equals n2 equals 7-2 equals 5. The comparison is in absolute value. Proportionality equals 0.01 scheduled equals 4.03. Proportionality equals 0.05 scheduled equals 2.57. We note that the value of t the calculated is smaller than t scheduled at significance level. Proportionality equals 0.01. Therefore, we accept the null hypothesis at this level and there is no statistically significant correlation. Also, the value t the calculated is greater than t scheduled at significance level. Proportionality equals 0.05. Therefore, we reject the null hypothesis and accept the alternative hypothesis at this level, and there is a statistically significant correlation. 5. Interpretation. There is a fairly strong direct correlation with statistical significance at the significance level. Proportionality equals 0.05 between knowledge and intelligence among students, so we are 95% sure of the results with a 5% margin of doubt. The solution is by SPSS. If it WASIG if the table is greater than or equal to 0.05, then we accept the null hypothesis. If it WASIG if the table is exactly less than 0.05, we reject the null hypothesis. Statistical significance. If there is 1 star above the correlation coefficient, then proportionality equals 0.05. If there are 2 stars above the correlation coefficient, then proportionality equals 0.01. We note from the table that the Pearson value is 0.78 at a significance level of 0.05 and that the statistical significance value ISIG equals 0.035, which is less than 0.05, so we reject the null hypothesis and accept the alternative hypothesis at this level. Statistical significance. If there is 1 star above the correlation coefficient, then proportionality equals 0.05. Hence, there is a somewhat strong direct correlation with statistical significance at the significance level. Proportionality equals 0.05 between knowledge and intelligence of students, so we are 95% sure of the results with a 5% margin of doubt.